Welcome viewers in my presentation on surface finish and surface integrity. Surface finish and surface integrity is important because functional performance of any product fully depends upon on this topic. Let me first define what is surface finish and what is surface integrity. This term surface integrity describes the state and attributes of a machine surface and its relationship to functional performance. In general, surface integrity can be divided into two aspects. First, the external topography of surfaces, mostly surface finish, and second, the microstructure, mechanical properties and residual stresses of the internal substrate layers. Surface integrity mainly divided into two topics, one is surface science, another is surface engineering. Surface science constitutes of surface topography, surface physics, surface chemistry and surface biology. And areas of surface engineering is design of surface layers, formation of surface layers, investigation of surface layers and utilization of surface layers. Now, what are the domains of surface integrity? Surface integrity and its importance in functional performance, surface structure characterization and evaluation, residual stresses and microstructure modification, as well as the mechanical properties of subsurface layer, characterization methods of surface integrity of machined surfaces by traditional and non-traditional techniques, surface integrity of micro and nano finished surfaces. Benefits of surface engineering is improved corrosion resistance through barrier or sacrificial protections, improved mechanical properties, for example, enhanced fatigue life, hardness or toughness, improved oxidation resistance, improved wear resistance, reduced friction energy losses, improved electronic or electrical properties, improved thermal insulations, improved biological properties and improved in fact aesthetic appearance. Then how do I quantify surface integrity? What are the parameters of surface integrity? This can be categorized as geometrical parameters, which is surface finish, surface texture, bearing curve parameters. Physical parameters includes micro hardness, residual stresses and of course microstructure. Chemical parameter includes affinity oxidation, adsorptions, chemi-absorptions, surface electrical polarizations and surface chemical reactions. Biological parameters include cell attachment, cell proliferations. Now, the data set for surface integrity are as follows. Minimum data set is, as I told you, surface finish, microstructure, micro crack indications, micro cracks, plastic deformation, phase transformation, intergranular attack, pits, tears, laps, protrusions, built up edge, melted and redeposited layers, and selective etching, micro hardness. But the standard data set are as follows. Minimum or standard data set are fatigue test, stress corrosion test, residual stress and distortion. In addition to these, some extended data sets are also there. Fatigue test extended to obtain design data, additional mechanical tests like tensile test, stress rupture, creep, other specific states like bearing performance, sliding friction evaluation and of course, sealing properties of surfaces. The geometrical parameters can be divided into two broad categories from the nominal surface. These are macro geometric deviations, which is mostly errors. They are the first and second order deviations called form errors and waviness respectively. Micro geometric deviations, third and higher order deviations, which correspond to the surface microform like surface roughness. Geometrical parameters includes RA or central line average value, which is arithmetic average roughness. The arithmetic average value of filtered surface profile determined from deviations about the central line within the evaluation length. The most popular parameter for a machining process and product quality control is surface roughness value. Then RT maximum peak to valley, the maximum peak to valley height of the filtered profile over the evaluation length. Next comes RZ value, which is average peak to valley height. It smoothens large deviations that are not representative of the surface finish corresponding to the RT value. Then comes RQ, which is root mean square or RMS roughness. The root mean square average of the roughness profile ordinates. It is more sensitive to peaks and valleys than RA gives. Then RP value, the value of the highest single peak above the center line. It is a sensitive to material removal from peaks. Then comes RPM, the mean leveling depth. It gives proper characterization of bearing and sliding surfaces and of course, substrates to be coated. Then the last parameter is RB, the deepest value below the center line. It is an indicator of oil retention or the mechanical behavior of the surface under high stress. The various manufacturing processes applied in industry produce the desired shape of the components within the prescribed dimensional tolerance and surface quality requirements. Surface topography and texture is a foremost characteristic among the surface integrity. Surface integrity magnitudes and properties imparted by the tools used in the process, mostly machining and especially their finishing versions. Another important properties of surface integrity is residual stress. In high speed machining imparts changes in surface layer, particularly with regard to microstructure, hardness variation, that is micro hardness, and residual stresses as well as influences on the material fatigue and corrosion. Residual stress is the internal stress distribution logged into a material. These stresses are present even after all external loading forces have been removed. This happens due to plastic deformation of the materials. There are a lot of techniques by which surface characterization can be performed. First, by measurement of surface roughness measurement, X-ray diffraction and electron diffraction will be presented for crystalline structures. X-ray energy dispersive analyzer, Auger electron spectroscopy and X-ray fluorescence are included for elemental analysis. X-ray photoelectron spectroscopy and secondary ion mass spectrometry for chemical composition analysis, the microcrystalline structure and dislocation density technology, transmission and electron microscopy. Even nowadays surface characterization can be done by image processing technique also. Here you are seeing some images taken by microscope here, then this is converted into grayscale image. From this grayscale image, peaks and value is denoted by image processing technique. You are see frequency diagram, peaks and value here small. Then from this you can characterize the surface texture, what are the parameters, surface roughness. This is a modern technique of surface texture characterizations. Now, surface integrity of micro and nano machine surface, how it can be performed? Micro and nano machining process are being developed that minimize the damage created due to the removal of materials at low and high material removal rates. In order to characterize the level of damage induced, the integrity of the surface requires to be measured. Here a schematic representation of a metal surface. Those surface at the top layer there are absorber cases and water vapor, then oxide layer, then bevel layer, then work layers. This is the corresponding dimensions of this. It is roughly about the top surface is 1 nanometer, then it is 10 to 100 nanometer, then 1 to 100 nanometer and then 1 to 100 micrometers. Then typical defects of machine surfaces are cracks are internal or external separations with sharp outlines, cracks requiring a magnification of 10 times or higher to be seen by a naked eye are called microcracks. Metallurgical transformation involves micro structural changes caused by temperature and high contact pressures. Included are phase transformations, recrystallization, alloy depletion, decarburization and molten and recast, resolidified or redeposited material as in electrical discharge machining. Residual stresses caused by process forces, deformations and temperatures due to plastic deformation of the materials. Then craters are shallow depressions, inclusions are more small non-metallic elements or compounds in the metal. Intergranular attack in the is the weakening a grain boundary by liquid metal embitterment or corrosion. Pits are shallow surface depressions, usually the result of chemical or physical attack. Plastic deformation is a severe surface deformations caused by high stresses due to friction or tool in manufacturing, which is the main cause of surface defects. Now, here you are seeing when you are machining a surface, this is the base material before machining and it is the post machining surface. You see how this surface is changing in the, in fact this is a wire zone of the materials, how this surface is changing. Now, This is a microscopic view of surface of a cutting tool. This is a wire or this is you see this is the wire difference, and this is another measurement, same measurement, but it is more wide. 320 micrometer, that means this length is 330 micrometers. How this figure, how this wire is progressed. Now another things, it is a SEM image of surface structure. When first one is when the cutting speed is, of course this structure is for cutting tool. First one is uncoated cutting tool where cutting speed is 150 millimeter per minute. This can be, you see there are two types of surface changes. One is addition, due to addition of workpiece and cutting tool materials. Another is abrasion of workpiece and cutting tool. This you see, there is this one. Again the same thing, when I am when this material is cutting with a higher speed, when the cutting tool is uncoated in nature and the cutting speed is 217 meter per millimeter, then this addition is, you see this is, if you compare this one, this is more prominent, and this is the abrasion of this cutting tool. In this lectures I have covered what is surface integrity, what are the measurable parameters of surface integrity, what are the common surface defects, what are the areas of a surface integrity. I hope you have enjoyed my lectures. We will meet once again in my next lectures. Till then, goodbye.